COVID-19, March 20th, 2020, Day 3. Here are the study questions for voltage, current, and resistance. I had to look all over the web to find one example of anything besides Christmas lights, which we've done to death, where any idiot engineer would be so dumb as to wire this as per number 1. But I found it. I found one photo. Here it is, a set of 6 spotlights. You wire up a 7th and your resistance goes up. Check your work. If your resistance goes up, you are working with a series circuit, and this is a manifestly dumb thing to be doing, because if one of these lights gets switched off, they will all go off. You'll have a break in the circuit, and you'll have no idea which one got switched off, which one got left on, or more importantly, if the light bulb blew out, you'll have no idea which one needs to be replaced. Also, by the way, if you have 300 ohms of resistance out of a 120 volt AC American outlet, that there is going to be a current of 0.4 amps or 400 milliamps. And if your lights need 1 ampere of current to flow, they will not be turning on. This is called a brown out. It means they don't have enough current to work. And to be fair, with 200 ohms of resistance, you were scheduled to have 0.6 amps of currents. They weren't even going to work before you wired the 7th off. What should you do to fix the problem? Well, you're going to need to lower the resistance. 7 spotlights not going to be happening out of that one outlet. Me personally, I would turn off several of the spotlights. You'll need to go down from 200 ohms to 120 ohms of resistance. So probably you're going to need to turn off 2 or 3 of them at the very least. Alternatively, you're going to need to take several of them and plug them into different outlets. No, not daisy chaining your extension cords. Do not plug an extension cord into another extension cord. You'll see why in the next problem. But you need to turn a few things off, unplug things, and then your 120 volts will be able to give you a higher current. Now, here is a setup you might find in the real world. It's as common as mud, and that's why we're going over it. In your dorm room, you plug in one piece of electronics after another. All of them plugged into one power strip, all that coming out of one outlet. You plug an extension cord into another extension cord. No! And turn it on. Your resistance goes down. Well, of course your resistance goes down because this is a parallel circuit. Why? Because all buildings are wired in parallel. All neighborhoods are wired in parallel, so you can turn appliances on and off separately. Also, because in a parallel circuit, if you add more devices, you add more options, you add more branches, you add more opportunities for the current to flow, you have a higher current and a lower resistance. Now, this is good because it means the lights don't have to be on and the music doesn't have to be blasting in order for you to talk on the phone or charge your cell. However, now that you've got everything on, you're going to have a good 4 amperes of current running, which is insanely large. I suppose your 1 ampere speakers would work on 4 amperes of current, but that's 4 times more than they need. You are in danger of overheating them. Aha! They have fuses set for a maximum of 2 amperes, means you're going to plug things in, you're going to turn them on, you're going to hear a little popping noise as you blow a fuse, and the speakers now don't work at all. Clap, clap, clap. Ooh, it gets better. Your dorm room is on a 4 amp circuit. You're running 4 amps of current, but you're not going to blow a fuse because there isn't a fuse box in your dorm room, because even if it was built in 1861, it's had its electrical system redone since then. This is a circuit breaker. The circuit breaker is going to trip, and all the electricity in your wing of your dorm, or if it's a small dorm, the whole dorm is going to shut down. And only the superintendent can go into the basement, go through all the rooms and switches, figure out what the problem is, and nobody will have any electricity for the rest of the evening until this happens. And you will be the least popular person in your dorm when they figure out that you, in defiance of all dorm rooms and Fermilab International safety specifications, you plugged an extension cord into an extension cord. You know why there are only 6 or 8 outlets in an extension cord? It's to prevent this happening. If you need to plug in more devices, find another outlet. Now it's funny because this really looks like the same problem you had with the spotlights in number 1, namely, you plug it in, you turn it on, and then everything goes dark. But it's not the same problem. This one is much more dangerous. That one was not enough current. This one is too much current. Interestingly enough, the solution is the same. Unplug a few of those precious devices, make do with less, find another outlet, and you'll be in good shape.